3, which is box plots. So today's objective to be able to draw and interpret box plots. As normal, before we start, let's just check our prior knowledge. So to be able to complete this lesson, you need to understand the terms median, lower quartile, upper quartile, and interquartile range. You need to be able to find the median, lower quartile, and upper quartile from a cumulative frequency graph. And you should be able to calculate the interquartile range. So that's the upper quartile, subtract the lower quartile. Please check you're happy with that before you move on. You should already have completed lesson 14.2 on cumulative frequency graphs before moving on to this lesson. Okay, so today then we're going to have a look at box plots, also known as box and whiskers diagrams. So a box plot is a way of displaying data, so an alternative to having a graph style. We're going to use a different form of diagram to help us today. So the table shows the results we obtained last lesson then. So in last lesson we looked at 100 people holding their breath and we drew a cumulative frequency curve, and from that we took some readings for our median, lower quartile and upper quartile. So I put those into a table, and I've also included in the minimum and the maximum, so they were taken from the grouped data table. So the lowest value in the table we had was 30 and the maximum value, the highest group, was 60. So at the bottom then I've put a scale, so this scale, it does go up in ones. I've not put all the numbers on just because for the moment it would give us too many things to be looking at, so it's easier to see without for the moment. Now the way we draw a box plot then is that we're going to draw a short vertical line to represent each of those 5 values. So we're going to start with the minimum at 30. So I've drawn there a small vertical line at 30, which is our minimum value. We're then going to draw another one for the lower quartile at 42. So that's there. So as I said, my scale is going up in ones for each of those lines. The same for median, upper quartile, and the maximum. So we've got 5 short lines above our scale. To turn those lines into a box plot, we join the lower and upper quartiles with a horizontal line. This produces the box, hence why it's called a box plot. And finally then, to finish that off, we're going to join from the center of the edge of the box to the minimums and the maximums, like that. And that's why it's sometimes called a box and whiskers diagram. So we have the box in the middle and we have the whiskers going out to the minimum and the maximum values. So the beauty of this diagram is that it shows us the overall spread of the data, so the range between the minimum and the maximum there, and it also shows us that middle 50%. So the interquartile range between the upper quartile and the lower quartile is shown by this box here. So this box represents the middle 50% of the data. From the upper quartile to the maximum is the highest 25%, and from the lower quartile down to the minimum is the lower 25%. So it splits our diagram into groups so we can see where the majority of the people are in our diagram. Okay, so make sure you've made a note then. You should be able to see where each of our 5 values, so we have minimum, lower quartile, median, upper quartile, and then maximum. So let's just check then that if you're given a box plot, you can read those values. So from the diagram, can you please pause the video and write down the minimum value, the maximum value, the lower quartile, the upper quartile, and the median? Okay, let's have a look at those then. So our first one then when we're asked for is the minimum value. So the minimum value is the short stick at the lowest end. So the lowest value we've got is 2. The maximum value at the very other end of the diagram there then, so we were between 10 and 12, so we've got 11. Our lower quartile, the first edge of the box there, is at 3. The upper quartile, the other edge of the box, is at 8. And the median is the line inside the box, which is at 6. Check that you've understood where each of those values have been read from before you move on. Okay, so let's have a look at how we go about answering a question on box plots then. So we've been given the data of the ages of 15 customers visiting a shop in the afternoon. So we can see they range here from 1 all the way up to 60. We're asked then to find the 5 values we need to draw a box plot and then to draw a box plot of the data. So our first value then is our minimum. So the minimum value is the lowest value in the data set. Our lowest value is 1. Now notice that this data has been sorted into order, smallest to largest first. That's really important, that if you're going to use a list of data, whenever we find averages or range from lists of data, we always put it in order, smallest to largest, before we start. So our minimum value, the lowest one, is 1. The next one we need to find is the lower quartile. Now, when we found the lower quartile in a cumulative frequency graph, we took the total number of data and divided it by 4. We're going to do something similar, but this time we're going to take the 15, which is the amount of people in the group, and we're going to add 1 to it first before we divide it by 4. The reason we're doing that is to make sure that we actually count all of the values. So we're going to do 15 plus 1 is 16 divided by 4 tells us it's the 4th value along the list. So counting from the beginning of the list, 1, 2, 3, 4, our lower quartile is 3. We're now going to find the median. So the median we find in a very similar way. We're going to have the number of people in the group 15 plus 1, but we're going to divide it by 2 this time. So that's the 8th value along the list. 1, 2, 3, 4, 5, 6, 7, 8 gives us the value of 24. The upper quartile, remember the upper quartile is 3/4 of the data. So our data, remember, is our 15 plus 1. So we need 3/4 of 15 plus 1, which is the 12th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That gives us the value 38. And finally then the maximum value is the biggest number in the list. So that's the one right at the end here. Our maximum value is 60. Please make sure you've made a note of those. So the key point then that we need to make sure is that when we're doing the lower quartile or the upper quartile, or to be honest, the median as well, that our data set, the number of pieces of data we have, we add 1 and then divide by 4 for the lower quartile, add 1 and divide by 2 for the median, and add 1 and divide by 4 and then multiply by 3 to get the upper quartile. You need to make sure you know those formula. If you don't add 1, what you'll find is that you'll get a value that is part way between two numbers. So when you try to count along the list, you won't actually end up on a whole number. Okay, so that was part A then, finding the 5 values we need. Now we've got those values, we should be able to draw our box plot. So I've just put those values into a table just to make it easy for me to see. So first then we need a scale. So our minimum was 1, our maximum 60. So I need a scale that goes between at least 1 and 60. So I've gone from 0 to 60. Again, I've used 1 line per number for this one, but it's up to you what scale you use. We draw our 5 short vertical lines. So we've got 1, then 3, 24, 38 and 60. We're going to draw our box between our lower quartile and our upper quartile, leaving our median inside the box. I'm going to draw our whiskers to the minimum and the maximum values, and that is our box plot. Okay then. Make sure you've made notes on how to find those different values and how to plot the box plot before you move on to have a go yourself. So remembering as well, the minimum to the lower quartile is the lower 25% of the population. The box represents the middle 50% of the population. And from the upper quartile to the maximum is 25% of the population. So although this line here is much longer than this one, they still both represent 25% of the people. Okay, so sometimes that can be confusing, but it's 25%, the box is 50, and the top line is another 25%. All right then, so now it's your turn. So you've got 11 students there and the time it took them to write an essay in minutes. You're asked to find the median, the upper and lower quartile, and then to draw a box plot for that data. So find your book and a ruler and a pencil and pause the video now and have a go at that. All right, so let's have a look at the solutions for those then. So our median time taken then, there are 11 people, so remember to do 11 plus 1 divided by 2 is the sixth value, which was 25 minutes. The lower and upper quartiles, 11 plus 1 divided by 4 means we needed the third value, and multiplying that by 3 meant we needed the ninth value. So we've got 25 minutes, 19 minutes and 28 minutes. Don't forget, to be able to draw the box plot, you also need to know the minimum and maximum. So just taking a note, the minimum is 15 and the maximum was 31. So again, I've just put them in a table just for ease of viewing there. So drawing those onto the box plot then. So again, you should have chosen a suitable scale. Remember, we needed to go from at least 15 to 31. And we draw our vertical lines. We draw in our lower quartile and our upper quartile, and then our whiskers. So yours should look something like that. Okay, so now that we're able to find the 5 values we need to draw a box plot and to be able to plot one, the main thing we use box plots for is for comparing data. So here we've got a table then of the ages of children in 2 different schools. We're asked then to draw the box plot for the ages of the children. We're going to draw them both on one axis and then we're going to compare them. So for our box plot then, we've been given all of the values, so we need to make sure we first choose a scale. So our smallest number from our minimum is 3, our maximum, the biggest, is 15, so it must be at least from 3 to 15. So we've got our scale along the bottom, given this axis label, age in years, so we know what we're doing. And we've plotted both of the box plots above that same axis. Okay, that's really important that we have them on the same axis. That makes them easy to compare. So when you're plotting out your axis, just do make sure that you've got the smallest to the largest. It's suitable for both sets of data. Once we've got our box plot then, as I said, the key thing we're going to do is the comparing now. So whenever we compare in maths, there are always 2 statements that we need to write about. The first statement is comparing the average. Now that could be the mean, the median or the mode. Now for box plots, we only have the median, so that's the one we're going to use. So an example of our statement might be, on average, the median shows us that the age of children in Club A of 9 years old is higher than in Club B, where it is 7 years old. So generally the children in Club A are older. So you'll notice I've included some key words there, the word average and the word median, so that we know which average it is I'm talking about. Also included some of the values that we found, so 9 years old and 7 years old. And finally, a statement of what that actually means to us. Number 2 then, our second statement. Our second statement should compare range or interquartile range. You can choose which is the most suitable depending on the data. But the range tells us the spread of the data. So if we have a small number, it means our values are similar, or consistent is a word we like to use. Or a large number means the values vary more, they're more spread out, or they're inconsistent. So there's lots of different ways you might word this. You might use the word spread, you might use those words similar, consistent, vary, inconsistent in your sentence. So an example of that sentence then. So the interquartile range for Club A is 5 years and for Club B is 3 years. Now I've worked those out, remember, doing the upper quartile, subtract the lower quartile for each of those clubs. And this means that the ages of children in Club A are more spread out. So again, keywords there, interquartile range to say which one I've used. So I could use the overall range or the interquartile range. the values of those interquartile ranges, so we have to calculate those and make sure they're accurate before we put them in, and then finally again what that actually means to our data. So to get full marks, your statements must relate to the subject in question, so in this case children's ages. So what that means is those final bits of the statement, the bit here where it says so generally the children in Club A are older, and here where it says this means the ages of children in Club A are more spread out. So I've related the data that I've got to the problem. If I were to just say the median and say that the median was 9 years and 7 years and that the interquartile range were 5 years and 3 years, I wouldn't get all of the marks for this question because I've not then explained what that's actually telling us. Okay, pause the video if you need to. Make a note of those sentences. It's perhaps a good idea to use those as a guide for writing your own sentences. So you can sort of take out the keywords and exchange them to relate to the topic you're looking at. All right then, so your turn. So you've been given a table with 2 species of birds and you've been given information of their mass in grams for those different birds. So again, you're asked to draw box plots for the masses of birds, both on the same axis, and then to compare them. So remember, with comparing, one statement about the median average and one about the interquartile range. Pause the video now, have a go at that in your maths book. Okay, so let's check our solutions for those then. So you should have box plots that look similar to that. Obviously you could have used a slightly different scale, so they may look a little bit different, but just check that those key values are marked in the appropriate places for yours. So it's quite easy to see just from our box plots that species A, look, has a very small interquartile range. Our box is quite small and it has a small overall range. For B, a bigger interquartile range and a bigger overall range. And looking at the median lines here, we can see that species A has a lower median than species B. So that's why we use these box plots one above the other. It makes it really quick to see those comparisons so we can write our sentences. So as a guide then, your sentence should be something like this. On average, the median shows us that the mass of species A, 60 grams, is lower than species B, where it's 65 grams. So the birds in species B are generally heavier. Okay, so again, keywords also included the appropriate values, making sure they're the correct values, and then finally our comparison. So what is that data telling us about those birds? Our second statement, the interquartile range for species A is 13 grams. So again, that's the upper quartile minus the lower quartile. And for B is 33. This means that species B has a greater spread of masses of birds. Again, we can see that really clearly from the diagram. Okay, make sure you're happy with your sentences. They do need to be nice, clear sentences with all the normal grammar, so commas, full stops, capital letters, etc. So whenever you see the word compare in maths, those are your 2 sentences, one on average and one on range, and that's throughout this entire statistics topic. Okay, well, thank you for working through this lesson today. Please click on the link to move on to the next lesson when you're ready.